Welcome, this is Benny Boy AF with my sixth installment of the game design series in Microsoft XNA.
Do you believe?
Let me just go ahead and start the game here and play through it a little bit, and then we'll talk about it later. What's new right now, we have a functioning playlist, which is just a list of cues using Exact Studio, uses SoundBank cues. And I've just made a list of string objects describing those cues, as well as giving a verbal description, including the song's author and copyright dates. Thanks, by the way, to Toiyaxe and SilentFutility for your musical contributions. They are super cool and make playing the game a lot more fun for me. Okay. At the lower left side of the screen, we have what everyone probably in the universe recognizes as a minimap. The larger of the squares represents a virtual kind of world. It doesn't actually exist anywhere. There's nothing printed to it right now, but a virtual world of 4,000 by 4,000 pixels. The whiter, more opaque box represents my screen, and you can see the proportion of that screen and where I am on the map. All right. Now, why clouds in space? I could have other things, little flotsam and jetsam floating around. Clouds was a pretty easy one to do quickly, and I think it looks kind of cool. You have to have something or you get this. Now that we're navigating freely, the world moves around the player, with the player at the center all the time, rather than flying around the screen. And what this means is if you don't have enough background stuff happening, then there's no cue about motion. Now, even if I add a boss here, I only get a relative clue. So I know I'm moving toward or away from the boss. I don't know if he's chasing me or I'm chasing him, or who's speeding up or slowing down. There's really no reference. Now watch what happens when I turn the clouds back on. Bam. There we go. Now we can kind of see he's approaching me. I'm flying away. I'm bravely defending. So what I've done is I've actually used a single image of one cloud region, and that's actually it right there. It looks like a little kind of horseshoe there, and we're just printing 100 copies of it all over the game world in various rotations and sizes and colors. And the cumulative effect, it's not quite perfected yet, but the cumulative effect is that you have a single kind of continuous cloud cover there. So it's a very elementary and beginning particle effect. So let's stop the game and look at how we do the cloud rotation. Here's an earlier version of the program, and our cloud data, our data structure, includes position, velocity, angle, scale, and color. Now, we need all these things to draw our clouds already, except for velocity. I haven't used velocity, and I could probably just delete it because I'm not using it right now. I am using angle, and the reason is if you're going to print the same image to the screen a bunch of times, you don't want it to look exactly the same. So if everything's the same size and angle, it just looks like one cloud cloned, which it is, but we don't want the player to be consciously aware of that fact. Okay, so we've got angle, scale. Changing the size also helps give the illusion that we have different cloud kind of activity going on there, and the color as well. Okay. Now, if I run this program, and this might take a while. Here we go. Orangey orange, orangey orange. Hello.
Do you believe? The beneficent Oz.
And we have these, so this is what I had an hour ago. And we have the clouds in there, and they look kind of alright. But they're not doing anything. They're not moving at all. They're just sitting there, being not very cloud-like, just patches of light smears on the screen. So I never planned to do anything like have them move or rotate, but now it looks like we're going to need to, because it just looks too dead. So let's look at the code and talk about how we'll go about doing that. So there's our cloud data. We have an angle, and I think what we could do to simulate just a little bit of motion is to just rotate the clouds very, very slightly so that you're always looking at them from a different angle, and hopefully they'll interact in random and interesting ways to give a better sense of kind of cloud activity. So what I'm going to do is add one more variable here, rate, and this will be the rate at which angle changes. So now we already have angle set up for each cloud. To change the angle, we'll need to know how fast we want to change it. That necessitates the one more variable. So once you've set up your data structure, you want to go into your initialization and prepare your game objects for use in the game. So we go down here, and here's where we're making new clouds there. Okay, so we have cloud data, temp cloud data, and what we do is we make a temporary cloud data, and then we add it to this list which we've made here. We have a random switch, and how that random switch works is well, I'll explain that in a minute. First, let's look at this stuff. So we have temp cloud data angle, temp cloud data position. Now, we've multiplied our random multiplier. The randomizer gives a scale between 0 and 1. Now, we have a 4,000 pixel virtual area. So all we need to do to get a random position in that area is multiply that random number generator times 4,000. Easy, right? Pi times 2 in radians is a circle. That's the same as 360 degrees. And then scale, so we have random times 2, which will give us a number from 0 to 2. And then we're adding 1, so we'll have somewhere between 1 and 3 for the size of each cloud. And the reason we do that is, why would you want a cloud with like 1/10 of normal size? It's going to look like a little pinwheel spinning around, so we don't want that. All right. What we don't have yet is our initialization for the rotation rate, and I'm not sure the exact amount we need to rotate by, but let's do something pretty small, say 0.02, and we want this to be plus or minus. So what we do is we subtract half our multiplier, and if you think about it, that means, okay, so we're going to have 0 to 0.02 minus 0.01. So we'll end up with minus 0.01 up to plus 0.01. So this should be half of this, and use minus. Okay. Next we have our random switch, which I started talking about but cut off. Now it's exclusive, which means it will never choose 6. It will be 0 to 5. And we have a case switch. So let's say this random number rolls a 0. You'll do this. And if the random number rolls a 1, you'll do this. Default is for all the things that aren't handled. So random 6 will give 0, 1, 2, 3, 4, 5. We have 0, 1, 2, 3. And then, 0, 1, 2. 3, 4, 5 will be handled in default. Okay, so case 0, I'm making a reddish cloud, case 1. We have 0.8 red, 1 green, 0.8 blue. That'll be a greenish cloud. We have red, green, blue. This is mainly blue. That'll be a bluish cloud. And in the last cloud, we have 1, 1, and 1. And that will be a grayish or white cloud. Okay, so I'm just dividing the clouds into random categories, so that we'll have clouds of slightly different shades. Now that we've got our rotation, we've got our clouds set up. At the end, we add temp cloud data to game clouds, and so this, each time we go through this, we're basically making one cloud. And we're doing that 100 times here, I up to 100. So we will have 100 clouds at the end. Okay, so now we've got our clouds. They have rotation rate information, and we need to go ahead and use that information in an update. I don't have an update cloud routine yet because the clouds were static. Once I set them up, they weren't moving at all. No need to update. Now we do need to update. So let's just go ahead and make a new routine here. Update clouds. And this error disappeared because we now have a routine for it. We're going to use a for loop, int I equals 0. And because we have our list of clouds in our main game object, we put game.clouds count, and that'll give us the number of clouds, which we already know to be 100, but which can change later. We go through the routine and then increment I. Okay, so we're going through all our clouds and doing nothing. What do we want to do? We want to change the angle by the rotation rate. Now, there's one thing we can't do, unfortunately. We can't change this data directly. So how we get around that is we make a temporary cloud data object and make it equal to the object we want to work on. Then we manipulate the temporary object, so the angle incremented by the rotation rate there. Okay, so the angle is now adjusted, and we have to go the other way and put that information back into our list. Oops, temp CD, okay. All right, so we go through our list, all the objects in our list, we get temporary data, we do something with that data, we send it back to the list. If you don't have this thing, sending it back, nothing will happen, because when you go to print the cloud, no data will have been changed. Okay, so we have our update clouds thing, and let's run it and see how it looks. I'll warn you right now, it takes a little while to get the game going with the screen capture program running. So how about that sporting team?
Do you believe?
And if I did this right, oh my god, well, it's pretty trippy. We have some really fast moving, fast rotating super clouds here, and it's too much. So I'm just going to go back and just tweak this a little bit. All we're going to do is change the rotation amount to something more reasonable. That looked like about 10 times too fast. So I'm going to kind of drop that down by, just add another 0 in there to make it a tenth as fast. And one last try, and hopefully this will be close enough that we can call it a day here. Orangey, orangey, orange. Hey, Apple.
Do you believe?
Still kind of fast, but there we go. We've got some cloud cover there, and got blown up by the Pope again. All right, so that's what I've been working on this time. I hope you guys enjoyed listening to to me ramble on about it. At least I enjoyed it, and I hope you'll be back for the next episode. See you later.